Solving systems of equations graphically in 2 minutes. When you graph a system of equations, you'll have 3 possible outcomes. The 2 equations will intersect at one point, therefore have one solution. The 2 equations will have the same slope, therefore they will be parallel and have no solutions. Or both equations might overlap because they're exactly the same equation, and therefore they have infinite solutions. When you have one solution, you name that x and y ordered pair point. When you have no solutions, you can use the empty set symbol, and when you have infinite solutions, you can use the infinity symbol. Let's get started. Here's a set of equations that will be drawn on the same pair of axes. I'm going to call this first one here equation A. I'm going to start by graphing the y-intercept at -2. Then I'm going to graph another perfect corner point by following the rate of change, which is the rise over the run, or the change in y over the change in x. So the change in y is +1, the change in x is +2. Rise 1, run 2. Rise 1, run 2. You draw as many perfect corner points as you can. You can also change the directions by changing both of the signs of the delta y and delta x values. So instead of up 1, right 2, we're going to go down 1, left 2. And this allows us to draw accurately the other half of the line. Now when you're labeling, you have 2 options. One is that you can label with the exact numbers from the equation like this, y equals 1/2 x minus 2, or you can do what I call my lazy man label. If you call it A, you can label it A. Let's graph the second equation here. Let's call this one B. The y-intercept is +3, and the slope is -2. Now remember, the rate of change needs 2 values. It's a ratio. So if you don't have a denominator, you write a 1. Delta y is -2, delta 1 is +1. Delta x, sorry. Down 2, right 1. Down 2, right 1. And so on. As you draw 1/2 of the line, you can reverse these signs to +2 and -1 instead. You can label it with its equation, or you can use the lazy letter labels. As long as you've given a label over here as A and B, you can do so on the graph as well. This is the solution of the system because it is a point that satisfies both equations. Let's take a look at another one. You'll notice these equations are written in standard form, which means they're not ready to be graphed. We don't have a y-intercept and we don't have a slope, but you could graph using the x and y-intercept method. And we use the intercept method because we know that an intercept has a 0 as one of its values. So if I place a 0 here, then I would have x is equal to -1, and that's an intercept. If I placed a 0 here, I would have -y equals -1. And if -y is equal to -1, then I can divide both sides by -1 and get my y-intercept. If my y-intercept is 1, then there's my line. Looks like it has a rise of 1 and a run of 1. So I can continue to make more points using that pattern. I don't have to, but it makes my line more accurate. I'm going to label this line A, and I'm going to label my graph A. Now for my second line. Looks like my x-intercept, when I divide both sides by 2, is 2. And it looks like my y-intercept, when I put a 0 here, is going to be 4. 1, 2, 3, 4, 1, 2. 1, 2, 3, 4, 1, 2. 1, 2, 3, 4, 1, 2. This allows me to draw these nice long lines, I'll label this V and this V, and that is my point of intersection. 1, 2.